This is a quick demo of Opsian's new OCaml profiling agent, which is part of a project sponsored by the Tezos Foundation to enable low overhead continuous profiling and monitoring across the Tezos network. So this is a flame graph of a Tezos validator on a node that's been running for a few hours. You'll see that boxes that share similar colors share similar modules. So we can see here these Tezos raw protocol boxes all share a similar color on the flame graphs, and that's to make identifying bits of code that are in the same part of the code base easier. The blue boxes, you might see these other boxes coming up blue on the flame graph. That's the same function on different parts of the flame graph. One of the problems with the flame graph is it's quite hard to find functions that are called all over your code base, and the idea here is by highlighting them we can make that much easier. So this is the profiler currently supports profiling across C and OCaml functions, and it can do so with very low overhead. We are running this on the Tezos node right now, and it supports CPU time profiling, but wall clock time and elapsed time is coming pretty soon. As it is right now, it can profile with less than a 1% impact on throughput. So for example, for a node snapshot restore, you can see restoration times are affected by less than 1%. So the idea is it's designed to be run continuously all the time and can be done so in a production manner. So you can see here I've zoomed in on the block validation, and you can see that there are cryptographic routines here that are responsible for validating the blocks. And we can see here that we've got some OCaml code further up that then calls into these native functions, which then call into these small C functions that are doing a lot of the actual validation work. Now, flame graphs aggregate from the top down. The other report that we have here that's very useful is hotspots. Now, hotspots does this the reverse way around. It aggregates from the bottom up, so it's really good for finding functions that are most often running when sampling is happening. So these are functions that are called for all over your code base. And here we can see that the majority of the time and samples are actually in cryptographic routines in the Hackle cryptography library. If we were to click on one, we can look at the line information, so we can see the most common lines that were executed. We can see the callers of that particular function, and then we can see the most common stack traces as well that these appeared in. And that allows us to dive in and really get a better understanding of what these code bases are doing. So that's just a really super quick overview of what we're working on right now, and we're really excited to get it into the hands of the Tezos and OCaml communities pretty soon.